Hey traveler, follow me. Tonight, we go back to the beginning of everything. Before we begin, I want you to do something for me. Wherever you are right now, let your body settle into where you're resting. Feel the weight of it, the quiet pressure of the surface beneath you. Let your shoulders drop just slightly. And take one slow breath in through your nose, hold it for just a moment, and let it go. Good. There is nothing you need to do tonight, no place you need to be, no problem you need to solve. The day is behind you now, and whatever it carried, you can set it down here, at the edge of the universe, and leave it for the morning. Some of what you hear tonight will find its way quietly into your mind, like light coming under a door. And some of it will drift past you like smoke in the dark, dissolving before you even notice it was there. Both of those things are perfectly fine. You are not here to learn. You are not here to remember. This journey is not a test, traveler. It is a gift. If somewhere along the way you close your eyes and don't open them again until morning, then we have done exactly what we came here to do. Sleep is not a failure. Sleep is the destination. Now, close your eyes if you haven't already, and follow me. 13.8 billion years ago, before the first star had ever burned, before space had edges or distances or directions, before time itself had learned to move, something happened, something so vast, so silent, so impossible to hold inside a single human mind, that even now, with all of our mathematics and all of our telescopes and all of our centuries of science, we can barely find the words to describe it. Tonight, we travel back to that moment, all the way back to the very first second of everything. Let's begin. Before the Big Bang, there was no space. There was no time. There was no darkness, because darkness is just space with no light in it, and space did not yet exist. There was no silence, because silence is just air with no sound moving through it. And there was no air, and there was no sound, and there was nothing for sound to move through. The word before had no meaning, because time itself had not yet taken its first step. Whatever existed before the beginning, if anything existed at all, is something our minds were simply not built to hold. And perhaps that is as it should be. Some things exist at the edge of what can be known. The beginning of everything is one of them. The Big Bang was not an explosion, not in the way we picture explosions. A violent burst of fire and pressure expanding outward into empty spaces. That image is wrong in the most fundamental way possible. There was no empty space waiting for it. There was no outward direction to expand into. The Big Bang was not something that happened inside the universe. It was the moment the universe itself began to exist. Space was not the stage. Space was born in that instant, along with time and matter and energy and every law of physics that would govern everything that followed. The universe did not appear inside something larger. It simply appeared. Everything you have ever seen, every mountain range, Every ocean, every grain of sand on every beach, every face you have ever loved, every city ever built, every book ever written, every star you have ever looked up at on a clear night was once compressed into a space so unimaginably small that the word small barely begins to describe it. Not smaller than a grain of sand, not smaller than a single atom, smaller than the smallest thing our instruments can currently measure. All of it, every atom of everything, pressed together into a single point of infinite density, infinite temperature, and infinite possibility. And then it expanded. The universe is approximately 13.8 billion years old. That number is so large that it resists any attempt to truly feel it. But try this. Imagine compressing all of cosmic history into a single calendar year. January 1st is the Big Bang. December 31st at midnight is right now, this moment, you resting quietly in the dark. In this cosmic calendar, the first stars don't appear until late January. Our solar system doesn't form until early September. The dinosaurs appear on December the 26th, and every human being who has ever lived, every civilization, every invention, every war, and every love story and every quiet night like this one exists only in the final 11 seconds of December 31st. 11 seconds out of an entire year. That is where we are. In the very first fraction of a second after the Big Bang, the temperature of the universe exceeded 1 trillion degrees Celsius. 1 trillion. A number so large that if you counted 1 degree per second, it would take longer than the current age of the universe just to count that high. At that temperature, not even atoms could form, not even the nuclei of atoms. The entire universe was a featureless, blindingly hot, impossibly dense sea of pure energy, with no structure, no shape, no darkness anywhere, and no possibility of life or light or silence. Just heat, just energy, just the raw, screaming potential of everything that would ever exist. The universe expanded faster than the speed of light in its earliest moments. This sounds like it should be impossible. We are told that nothing can travel faster than light, and that is true for objects moving through space. But in those first instants, it was not objects moving through space. It was space itself that was stretching, and space has no speed limit. The fabric of reality was expanding, carrying everything within it along for the ride at speeds that make our fastest spacecraft look perfectly still. This expansion has never fully stopped. The universe is still growing right now, in every direction, at every point simultaneously. It is growing as you rest. Within the first second of existence, the 4 fundamental forces of nature separated from what had once been a single unified power. Before that separation, there was one force, one elegant, unified law governing everything. And then, as the universe cooled, it split. Gravity peeled away first, then the strong nuclear force, then electromagnetism and the weak nuclear force divided from each other. 4 forces, each governing a different aspect of reality, each essential, each irreplaceable. And somewhere In the deepest corners of theoretical physics, scientists are still searching for the equations that would reunite them, that would show us what that original single force looked like before the universe had its first birthday. The very first particles ever to exist in the universe were called quarks. They appeared within the first millionth of a second, tiny, fundamental units of matter swimming in an ocean of pure heat that scientists call the quark-gluon plasma. This was a state of matter so extreme, so alien to anything we encounter in our daily lives, that it has only been recreated briefly in the most powerful particle accelerators on Earth, and even then only for the briefest possible instant. In those first microseconds, the universe was nothing but quarks and the force that binds them, a churning, formless sea of raw matter, with no atoms, no molecules, no structure of any kind, just the ingredients, waiting to become something. For every billion particles of antimatter that were created in the earliest moments of the universe, there were 1,000,000,001 particles of matter, one extra, one more than the other side. That asymmetry, that tiny, almost invisible imbalance, is the reason the entire universe exists, because matter and antimatter, when they meet, destroy each other. They annihilate completely, leaving nothing but a burst of energy. And in those first moments, that is exactly what happened. Billions upon billions of particles colliding and destroying each other in flashes of pure light. But because there was one extra matter particle for every billion pairs, when the annihilation was over, something was left, a tiny remnant, a small excess of matter, and from that small excess, every star, every planet, every ocean, every living thing, every thought that has ever been thought, was eventually made. Think about that for a moment, traveler. You exist because of a 1 in a billion asymmetry that occurred in the first fraction of a second after the Big Bang. If that ratio had been perfectly equal, if matter and antimatter had been created in exactly the same quantities, the universe would have destroyed itself before it had even begun. There would be nothing. No space, no time, no light, no possibility of anything ever existing. Instead, there was one extra particle per billion, and from that one extra particle, multiplied across the entire universe, came everything. The stars came from that. The Earth came from that. You came from that. You are the universe's most improbable consequence. And yet, here you are, breathing quietly in the dark. The first true atoms in the universe were not created during the Big Bang itself. In those first moments, it was simply too hot. The universe had to cool first, and cooling, at cosmic scales, takes time. For 380,000 years after the Big Bang, the universe remained a hot, opaque, glowing fog of free electrons and protons, too energetic to combine into atoms. Light could not travel freely through it. Every photon that tried to move was immediately scattered by the dense fog of particles. The universe was luminous, but blind, brilliantly lit, but completely opaque. And then, After 380,000 years of cooling, the temperature finally dropped to the point where electrons could be captured by protons. The first hydrogen atoms formed, and the fog lifted. The moment the first atoms formed is called the epoch of recombination, and in that moment, for the very first time in the history of the universe, light could travel. The fog cleared, and a flash of ancient light was released in every direction simultaneously, a last glow of the early universe, freed at last to move through the newly transparent cosmos. That light is still traveling today. It has been traveling for 13.8 billion years. It is everywhere around us right now, a faint, cold afterglow of the Big Bang itself, stretched by the expansion of the universe into microwave radiation. Scientists can detect it, they can map it, they call it the cosmic microwave background. And in its faint temperature variations, in its tiny ripples and fluctuations, is written the story of everything that the universe would eventually become. When you look at the static on an old television set, a small percentage of that interference comes from this ancient light, the leftover glow of the Big Bang, still moving, still arriving, still filling every corner of the universe. After 13.8 billion years, it has traveled further than any human mind can easily imagine. It carries information about a time before stars existed, before galaxies existed, before any structure in the universe had formed at all. It is the universe's oldest photograph, and a tiny fraction of it lands on your television screen and becomes static, and you change the channel without knowing what you almost saw. After the first light was released, the universe went dark again. There were no stars yet. There were no galaxies. There was no light source of any kind anywhere in the observable universe. For hundreds of millions of years, the cosmos existed in a darkness more complete than anything we can experience on Earth. Scientists call this the cosmic dark ages, not because anything bad was happening, but because the universe had not yet learned to shine. It was full of hydrogen and helium gas, slowly, quietly drifting, slowly, almost imperceptibly, gathering under the pull of gravity, building up density in some regions and leaving others emptier, preparing in its slow and patient way for the moment the first stars would ignite and end the darkness forever. The first stars to ever exist in the universe were nothing like our sun. They were enormous, hundreds of times more massive, burning with a ferocity that the modern universe has never seen again. They formed from the primordial hydrogen and helium of the early universe, collapsing under gravity in regions that were slightly denser than their surroundings, heating up as they collapsed until the pressure and temperature at their cores reached the threshold for nuclear fusion, and they ignited. And for the first time in hundreds of millions of years, the universe had light again, not the glow of the Big Bang, not the fading warmth of the cosmic microwave background. New light, made by stars. The darkness of the cosmic dark ages ended not with a single event, but with stars switching on one by one across the vast and empty universe. These first stars burned so hot and so fast that they exhausted their fuel relatively quickly, where our sun will burn steadily for 10 billion years. The most massive of the first stars may have lived for only a few million. Brief, brilliant, violent lives. And when they died, they did not die quietly. They exploded in supernovae of almost unimaginable energy, events so luminous that a single exploding star could briefly outshine an entire galaxy of hundreds of billions of other stars. And in those explosions, something new was created, something the universe had never contained before. Heavy elements, carbon, oxygen, nitrogen, iron, silicon, all the elements that would eventually make planets and oceans and living things. The first stars died so that everything else could exist. Every element heavier than hydrogen and helium was forged inside a dying star. This is not a metaphor or a simplification. It is precise, verified, scientific fact. The carbon in your body was created in the core of a red giant star that expanded and shed its outer layers billions of years before our solar system formed. The oxygen you are breathing was produced in the nuclear furnace of a massive star in its final stages of life. The iron that carries oxygen through your blood was synthesized in the last seconds of a star's existence, just before it exploded. The calcium in your bones, the phosphorus in your DNA, the nitrogen in every protein in your body, all of it made in stars. All of it scattered across space by stellar explosions. All of it eventually gathered by gravity into a new solar system, into a planet, into an ocean, into life, into you. You are made of stardust. This is perhaps the most remarkable true sentence in all of science, not a poetic exaggeration, not a comfortable metaphor designed to make us feel connected to the cosmos, a precise, literal, scientific statement. The atoms in your hands were once inside a star. The atoms in your lungs were forged in nuclear reactions at temperatures of millions of degrees. The atoms in your heart were scattered across interstellar space by an explosion so vast it briefly outshone a galaxy. And then, over billions of years, gravity gathered them into a nebula, into a solar system, into a planet, into an ocean, into a cell, into you. The universe spent 13.8 billion years building the ingredients for this moment, for you resting quietly, made of ancient starlight. The oxygen you are breathing right now, the specific oxygen atoms passing through your lungs in this moment, were created inside a star that no longer exists. That star was born from a cloud of gas and dust. It burned for millions or billions of years. It fused hydrogen into helium, helium into carbon, carbon into oxygen, in a chain of nuclear reactions at its core, sustained by the weight of its own mass pressing inward. And when its fuel ran out, it died. It scattered those oxygen atoms into space. They drifted for millions of years. They became part of a molecular cloud. That cloud collapsed into our solar system. Those atoms became part of the Earth. They dissolved into the early oceans. They were used by early life. They were breathed by dinosaurs. They were breathed by your ancestors. And now, tonight, they are passing through your lungs. You are breathing the breath of stars. The first galaxies began forming approximately 200 million years after the Big Bang. They were small and chaotic compared to what we see in the universe today. Dense clusters of young, rapidly forming stars, held together by the gravity of vast amounts of dark matter, colliding with each other, merging, growing. The early universe was a violent, turbulent place. Galaxies crashed into each other at enormous speeds. Supermassive black holes at their centers blazed with energy as they consumed vast quantities of gas. And slowly, over billions of years, the chaos settled. The violent early galaxies calmed, merged, organized themselves, grew spiral arms, became the grand, stately structures we see when we look at the deep sky today. Our own Milky Way galaxy began forming approximately 13.5 billion years ago, just 300 million years after the Big Bang. It has been growing and evolving ever since, absorbing smaller satellite galaxies, building new stars from the gas it contains, slowly organizing itself into the vast, barred spiral that it is today, 100,000 light years across, containing somewhere between 100 and 400 billion individual stars, each one a sun, many of them with their own systems of planets orbiting in the dark. The Milky Way is ancient. It is enormous, and we live in one of its quiet outer arms, 26,000 light-years from the chaotic, brilliant center, in a relatively peaceful neighborhood, orbiting the galaxy's heart at 828,000 kilometers per hour, completing one full orbit every 225 million years or so. The Milky Way contains somewhere between 100 and 400 billion stars. Scientists cannot count them directly. The number is estimated from the total mass of the galaxy and the typical mass of the stars within it. But here is the thing that truly resists comprehension. The Milky Way is just one galaxy. One. There are an estimated 2 trillion galaxies in the observable universe. 2 trillion galaxies, each containing hundreds of billions of stars. When you try to calculate the total number of stars in the observable universe, you arrive at a number larger than the number of grains of sand on every beach and every desert on the entire surface of the Earth. A number so large that it is essentially meaningless to the human mind, and every single one of those stars is a sun, many of them with worlds. The observable universe is 93 billion light-years across, but this is not the entire universe. It is only the part we can see, the part whose light has had time to reach us since the Big Bang. The universe beyond that boundary is not empty. It continues in all directions, perhaps forever. We cannot see it. We cannot reach it. We cannot even send a signal to it that would ever arrive, because the expansion of space is carrying those regions away from us faster than light can travel. There may be regions of the universe that will never, under any circumstances, ever be in contact with us. We are islands in an ocean that may have no shore. When you look at the night sky, you are not seeing the universe as it is, you are seeing the universe as it was. The light from the nearest stars takes years to reach your eyes. The light from distant galaxies takes millions or billions of years. When you look at the Andromeda Galaxy with the naked eye, the light entering your eyes left that galaxy 2.5 million years ago, before our species existed. When scientists observe the most distant galaxies with their most powerful telescopes, they are seeing those galaxies as they were 13 billion years ago, when the universe was young and wild and nothing like it is today. The night sky is a time machine. Every point of light is a different moment in the past, and in some deep sense, every time you look up, you are looking backward through the history of everything. The universe is not just expanding, it is accelerating. Galaxies are moving away from each other faster and faster with every passing year. This was discovered in 1998, and it shocked cosmologists. The expectation was that gravity would be slowing the expansion down. Instead, something is pushing it faster. Something is overcoming gravity on the largest scales and causing the universe to pull itself apart at an ever-increasing rate. Scientists call this force dark energy. They gave it that name because they have no idea what it is. It makes up approximately 68% of the total energy content of the universe. It is the dominant feature of the cosmos, and we know almost nothing about it. It is the largest mystery in science. The universe is being driven apart by something we cannot see, cannot measure directly, and cannot explain. And it has been happening for billions of years. Dark matter makes up another 27% of the universe. It does not emit light, it does not absorb light, it does not reflect light or interact with it in any way. It passes through ordinary matter as if it isn't there. You cannot see it, you cannot feel it. Right now, dark matter is passing through you, through the walls of the room you're in, through the earth beneath you, as if none of it exists. We know it is there only because of its gravitational effects on the things we can see. Galaxies rotate in ways that only make sense if they contain far more mass than their visible stars account for. Galaxy clusters bend light in ways that reveal invisible mass. The universe's large-scale structure could not have formed without dark matter's gravitational scaffolding. It is the skeleton of the cosmos, and we have no idea what it is made of. Everything we can see, every star, every planet, every galaxy, every atom of air in this room, every molecule of water in every ocean on Earth, makes up only about 5% of the total universe. 5%. The remaining 95% is dark matter and dark energy. Things we cannot see, things we do not understand, things that shape the entire structure and fate of the cosmos. While remaining completely invisible to us, we live in a universe that is 95% unknown. We are surrounded by mystery in every direction. And perhaps that is the most honest thing science has ever told us about where we are. Einstein showed us something extraordinary about the nature of gravity. It is not a force in the traditional sense. It is a curvature, a bend in the fabric of space and time itself caused by the presence of mass and energy. Every object with mass, every star, every planet, every atom curves the space around it like a heavy ball resting on a stretched rubber sheet, and other objects moving through that curved space follow the curves, not because they are being pulled, but because the straightest possible path through curved space is itself curved. This insight changed everything. It told us that space is not an empty stage on which events occur. It is a dynamic, flexible, physical thing that bends, stretches, ripples, and responds to the matter and energy moving through it. The universe is not a container, it is a participant. Time is not fixed. This is one of the most unsettling things physics has ever discovered about the universe. Time passes at different rates depending on how much gravity surrounds you and how fast you are moving. A clock at the surface of the Earth ticks slightly slower than a clock in orbit where gravity is weaker. The difference is tiny, but it is real and it is measurable, and GPS satellites must account for it, or navigation errors would accumulate rapidly. Near a black hole, the difference becomes dramatic. A clock hovering near the event horizon of a black hole would tick so slowly, compared to a clock far away, that what felt like minutes near the black hole could correspond to years or centuries or millennia elsewhere. Time is not a universal constant. It is a local experience, and it flows differently depending on where you are. Gravitational waves are ripples in the fabric of space and time itself, traveling outward from the most violent events in the universe like ripples on the surface of a pond. Einstein predicted their existence in 1916. For 100 years, they remained undetected because the distortions they cause are almost impossibly small. And then, on September 14th, 2015, two enormous detectors, each with arms 4 kilometers long, felt a wave pass through them. A wave created 1.3 billion years ago when two black holes, each many times the mass of our Sun, spiraled into each other and merged in a collision of unimaginable violence. The wave that reached Earth was so small that it distorted the detectors by less than 1,000th the width of a proton. And yet, it was detected. For a fraction of a second, the universe spoke, and we heard it. The universe has no center. This is not a statement about our ignorance or lookable. It is a statement about the geometry of the universe itself. Because the universe is expanding uniformly in all directions from every point simultaneously. Every point in the universe is equally the center of the expansion. If you were in a galaxy 1 billion light years from here, all other galaxies would appear to be moving away from you in every direction. You would appear to be at the center. From our galaxy, we appear to be at the center, but neither is the actual center, because there is no actual center. The universe began everywhere at once. Every point in space was the beginning, And every point in space is still the beginning, in a sense, because the expansion that started at the Big Bang continues everywhere, equally right now. Black holes do not pull things in like a cosmic vacuum cleaner. They are not hungry voids waiting to swallow the universe. A black hole is simply an object whose mass is so concentrated, packed into such a small volume that the escape velocity at its surface exceeds the speed of light. Nothing can escape from inside the event horizon because nothing can travel faster than light. But from a safe distance, a black hole is just a very massive object. Its gravitational pull at large distances is no different from any other object of the same mass. If our sun were magically replaced by a black hole of exactly the same mass, the Earth would continue orbiting exactly as it does now. Nothing would change, except that the sky would go dark and the solar system would become very, very cold. At the center of our own Milky Way galaxy, 26,000 light years from where you are resting right now, sits a supermassive black hole called Sagittarius, a star. It has a mass approximately 4 million times that of our Sun. It is surrounded by a swirling disk of gas and dust that glows brilliantly as material falls inward. Stars orbit it at extraordinary speeds, completing full orbits in just a few years, compared to the 225 million years our solar system takes to orbit the galactic center. In 2019, astronomers released the first image ever taken of a black hole's shadow, a different supermassive black hole in a different galaxy, a dark circle surrounded by a glowing ring of superheated gas. For the first time in history, we could see the boundary where the universe's laws break down, the edge of the known. Neutron stars are among the most extreme objects in the universe. They form when a star much larger than our Sun exhausts its nuclear fuel and collapses under its own gravity, so quickly and so violently that the collapse itself triggers a supernova explosion. What remains after the explosion is the collapsed core, a sphere of neutrons packed together so tightly that all the empty space normally found inside atoms has been crushed out of existence. A neutron star might contain 1.5 times the mass of our entire Sun, in a sphere only about 20 kilometers across, a sphere you could drive across in about 15 minutes. And a single teaspoon of its materials, and if you could somehow bring it to Earth, would weigh approximately 1 billion tons. Some neutron stars spin hundreds of times per second. These rapidly rotating stars, called pulsars, emit beams of radio waves or X-rays from their magnetic poles. Beams that sweep through space like a lighthouse beam as the star rotates. Every time that beam sweeps past Earth, our radio telescopes detect a pulse, precise, regular, like a clock. The first pulsar ever discovered pulsed so regularly that astronomers initially could not believe it was natural. They gave it the designation LGM-1. Little green men, because the only explanation they could initially imagine was that it was a signal from an intelligent civilization using a precise astronomical clock to announce their existence across the galaxy. It wasn't, but for a brief extraordinary moment. It seemed possible. When two neutron stars orbit each other closely enough, they spiral together over millions of years, losing energy by radiating gravitational waves until they finally collide in an event called a kilonova. A kilonova is one of the most energetic events the universe can produce. In the collision, the extreme pressures and temperatures create conditions that forge heavy elements, gold, platinum, uranium, and others, in enormous quantities. Scientists detected a kilonova for the first time in 2017 and confirmed that it produced more gold than the mass of our entire Earth. Many times over, every gram of gold that has ever existed on this planet, every gold coin, every piece of jewelry, every golden thing in all of human history, was forged in the collision of two dead stars. It arrived here on asteroids billions of years ago and sank into the Earth's mantle. We dug it up. We called it precious. We did not know what it had been through to get here. Our solar system formed approximately 4.6 billion years ago from a vast, slowly rotating cloud of gas and dust, a nebula, drifting quietly in one of the Milky Way's spiral arms. That cloud was not primordial. It was not made of the original hydrogen and helium from the Big Bang. It was made of material that had already been through stars. The gas and dust in that cloud contained oxygen and carbon and iron and silicon, all the heavy elements forged in previous generations of stellar life and death. Our solar system is a recycling project. It was built from the remains of things that came before it. The sun you see in the sky, the ground beneath your feet, the atoms in your body are all second-hand, third-hand, fourth-hand. They have been through more than we can easily imagine. The event that triggered the collapse of our solar system's nebula, the event that set in motion everything that would eventually lead to the Earth, the oceans, life, and you, may have been a nearby supernova, a star exploding in our cosmic neighborhood, sending a shockwave through the gas cloud, compressing it beyond the point where gravity could take over. A death giving birth to a beginning. In this way, we are the children of a star we will never know, a star that lived and burned and died before our sun existed, a star whose explosion shaped everything. Its name, if it had one, is lost. Its existence is written in the chemistry of every atom on Earth. As the nebula that became our solar system collapsed inward under gravity, it began to spin faster. This is a consequence of the conservation of angular momentum, the same principle that causes a figure skater to spin faster when they pull their arms inward. The spinning, collapsing cloud flattened into a disk. At the center, material accumulated and heated under the pressure of its own mass, until the temperature and pressure at the core became high enough to ignite nuclear fusion. The sun lit up, and the remaining material in the disk, the gas and dust that hadn't fallen into the center, began to stick together. Grains of dust became pebbles. Pebbles became rocks. Rocks became planetesimals. Planetesimals became planets. The entire process, from collapsing cloud to a solar system with planets, took only a few million years. A blink, in cosmic time. The Sun contains 99.86% of all the mass in our solar system. Every planet, every moon, every asteroid, every comet, every ring system, every grain of interplanetary dust combined, all of it together makes up only the remaining 0.144%. Jupiter, the largest planet, accounts for most of that tiny fraction. Saturn accounts for much of the rest. Earth, the planet you are lying on right now, is such a small fraction of the solar system's total mass that expressing it as a percentage requires many decimal places before you reach a non-zero digit. And yet, this tiny fraction of a fraction contains every ocean, every mountain, every living thing, every thought, every dream that has ever occurred on this world. Earth formed approximately 4.54 billion years ago. In its earliest days, it was almost unrecognizable. The surface was molten rock, a global magma ocean, constantly being stirred and reheated by the impacts of asteroids and planetesimals raining down from the young solar system. There were no oceans. There was no breathable atmosphere. There were no continents. There was nothing stable enough to stand on, and nothing capable of standing. The early Earth was a violent, brilliant, hellish world, slowly cooling, slowly solidifying, slowly becoming something that might one day be called home. It took hundreds of millions of years, but eventually the rain of asteroids zeered, the surface cooled, solid rock appeared, and something extraordinary began to happen. Our moon was born from catastrophe, approximately 4.5 billion years ago, when the Earth was still young and molten, a body roughly the size of Mars. Scientists call it Theia, traveled through the inner solar system on a collision course with Earth. The impact was not a gentle collision. It was an event of such violence that it partially vaporized both worlds. The energy released was almost beyond calculation. Rock and magma were flung into orbit around the Earth in enormous quantities, a ring of debris spinning in the dark, slowly over millions of years, coalescing under its own gravity into a single body, the moon. Every time you look at the full moon, you are looking at the result of the most violent event in Earth's history, a collision that nearly destroyed our planet and instead gave us something beautiful. Without the moon, Earth would be a fundamentally different world. The moon stabilizes our planet's axial tilt, the angle at which Earth leans relative to its orbit around the Sun. Without that stabilization, Earth's tilt would shift chaotically over millions of years, swinging between extremes that would cause dramatic, wild swings in climate across the entire planet. The relatively stable seasons we experience, the predictable pattern of summer and winter, of warmth and cold, depend on the moon keeping our planet's lean within a manageable range. Some scientists believe that without this stability, complex life might never have been able to evolve. The moon is not just a light in the night sky. It may be one of the reasons we are here. The first life on Earth appeared approximately 3.8 billion years ago, just 700 million years after the planet formed. In geological terms, almost immediately. These were not complex creatures, they were single-celled organisms, simpler than the simplest bacteria, alive today, living in the early oceans in conditions that would be toxic to almost every form of life we know today. No oxygen, extreme temperatures, high radiation, and yet life began. In the chaos and violence of the early Earth, in the warm, chemistry-rich waters of the young oceans, something crossed the threshold from chemistry into biology. Something began to reproduce. Something began to evolve. We do not know exactly how. We do not know exactly where. But we know it happened because we are here. For most of Earth's 4.5 billion year history, life was invisible. Single-celled organisms, bacteria and archaea, dominated the planet for over 3 billion years. 3 billion years of microscopic life. 3 billion years of evolution, adaptation, competition, cooperation, all happening at a scale too small to see. The oceans were full of life, but you could have looked at them and seen nothing. You could have held a handful of water from any ocean on Earth 2 billion years ago and seen nothing but water, while holding billions of living organisms in your palm. Life was everywhere, and it was invisible. It would remain that way for most of the planet's history. The oxygen in the atmosphere you are breathing right now was not always there. For the first half of Earth's history, roughly the first 2 billion years, the atmosphere contained almost no free oxygen. And then, approximately 2.4 billion years ago, something happened. A group of single-celled organisms called cyanobacteria, tiny, ancient, almost impossibly simple, evolved the ability to perform photosynthesis, to use sunlight and carbon dioxide to make food, and release oxygen as a waste product. And they began doing it everywhere, in every ocean, for hundreds of millions of years. The oxygen they released dissolved in the oceans first, reacting with iron to form vast deposits of iron oxide on the ocean floor. And then, when the oceans could hold no more, the oxygen began to enter the atmosphere, slowly at first, then more and more, until the atmosphere was transformed. An event so significant that scientists call it the Great Oxidation Event. The atmosphere of an entire planet changed by the waste product of a single-celled organism. The light that is warming you right now, or that warmed you today, took 8 minutes and 20 seconds to travel from the surface of the sun to the Earth. At the speed of light, 150 million kilometers in 8 minutes and 20 seconds. But that light was not produced at the surface of the sun. It was produced in the sun's core, in nuclear reactions taking place at temperatures of 15 million degrees Celsius. And from the core, it did not travel to the surface in 8 minutes. It took between 10,000 and 170,000 years. The interior of the sun is so dense, so full of particles that absorb and re-emit radiation, that a photon of light produced in a nuclear reaction at the core bounces and scatters and wanders through the solar interior for tens of thousands of years before finally reaching the surface and escaping into space. The warmth you feel on your skin comes from a process that began inside the sun long before humans existed. Our solar system orbits the center of the Milky Way at approximately 828,000 kilometers per hour. This is not a speed that registers in human experience, but even at this extraordinary velocity, the Milky Way is so vast that one complete orbit takes between 225 and 250 million years. Astronomers call this a galactic year. We are currently in the midst of our solar system's approximately 20th orbit around the galactic center since the solar system formed. The last time we were in this exact position, the Triassic period was just beginning on Earth. The first dinosaurs were only recently appearing. The continents were arranged very differently. The world was unrecognizable, and in another galactic year, another 225 million years, the sun will be here again. But the Earth will be very different, and whatever is living on it will not be us. The nearest star to our sun is Proxima Centauri, 4.24 light-years away. Light travels at approximately 300,000 kilometers per second. Even at that speed, it takes over 4 years to cross the gulf between our sun and the nearest other star. The Voyager 1 spacecraft, launched in 1977, is the most distant human-made object ever built. It has been traveling continuously for nearly 50 years. It is now approximately 23 billion kilometers from Earth. And at its current speed, it would take over 70,000 years to reach even the nearest star, if it were traveling in that direction, which it is not. The distances between stars are not large. They are beyond any scale that the human mind was built to genuinely comprehend. The universe is not just big, it is big in a way that resists understanding. Proxima Centauri has at least one rocky planet orbiting within its habitable zone. The range of distances from a star where liquid water could exist on a planet's surface. This planet, called Proxima b, is only 4.24 light-years away, the closest potentially habitable world we know of beyond our solar system. We do not know if it has an atmosphere. We do not know if it has water. We do not know if anything lives there. We do not know if anything has ever looked up from its surface at a sky full of unfamiliar stars and felt the same quiet wonder that you feel when you look up at yours. But it is there, just over 4 light-years away, closer in cosmic terms than almost anywhere else. And we cannot reach it, not yet, not with anything we have built. Scientists have confirmed the existence of more than 5,500 planets beyond our solar system. They are called exoplanets. They have been found orbiting all kinds of stars, young stars and old stars, large stars and small ones, stars in binary systems orbiting each other, stars near the galactic center, and stars in the quiet outer arms. Planets are not rare. They are ordinary. They appear to be a natural consequence of how stars form. Almost every star seems to have them. Current estimates suggest there may be more planets in the Milky Way than there are stars. More than 100 billion worlds, most of them in permanent darkness, many of them frozen, some of them perhaps warm and wet and full of something we would recognize as life, and we have found only a tiny fraction of them. The Fermi paradox is one of the most haunting questions in science. It goes like this: the universe is enormous and ancient. It contains 2 trillion galaxies, each with hundreds of billions of stars, many of them with planets. Life on Earth appeared relatively quickly after the planet formed. Intelligence evolved, civilization developed. If this can happen once, why not again? Why not many times? Why not millions of times across billions of years? And yet, in all our searching, in all our listening, in all our scanning of the sky for signals, we have found nothing. No message, no signal, no evidence of any other mind looking back at us from the dark. The universe appears to be empty of intelligence beyond our own, and nobody knows why. Perhaps intelligent life is extraordinarily rare. Perhaps the steps required to go from simple chemistry to complex life to intelligence to civilization are so improbable that they have only happened once in the observable universe on this small blue planet. Perhaps civilizations arise regularly, but collapse before they develop the ability to communicate across interstellar distances. Perhaps the signals are there, but we are not yet capable of recognizing them, or perhaps the universe is simply so vast, and the distances so immense, that even in a cosmos teeming with life, the chances of 2 civilizations being in communication, range of each other at the same moment in cosmic history, are vanishingly small. We do not know. The silence of the sky is the universe's greatest unanswered question. The cosmic web is the largest structure in the observable universe. If you could somehow rise above the universe and look down at it from an impossible distance, you would see a vast 3-dimensional network of filaments, enormous threads of galaxies and dark matter, hundreds of millions of light years long, crisscrossing in every direction, surrounding vast, empty regions called voids where almost nothing exists. The overall structure looks uncannily like a neural network, like the inside of a brain, like a web of neurons firing and connecting. Scientists have noticed this resemblance. They have measured it. The statistical properties of the cosmic web and the neural networks of the human brain are strikingly similar. The universe organized itself at the largest possible scale into something that looks like a mind. The largest known void in the observable universe is called the Boötes void. It is approximately 330 million light-years across. To put that in perspective, the observable universe is 93 billion light-years across, and the Boötes void takes up a significant fraction of that. It contains almost nothing. Where there should be thousands of galaxies, there are only a sparse handful. No one knows with certainty why it exists. It may be the result of the way dark matter and dark energy drove the formation of large-scale structure. It may be the remnant of some very early process in the universe's history, or it may simply be the universe's way of reminding us that emptiness, profound, vast, almost total emptiness, is the default state of existence, and that everything we know and love is the exception. Space is almost completely silent. Sound is a compression wave, a pattern of pressure variations moving through a medium. In the near-perfect vacuum of interstellar space, there is almost no medium for sound to travel through. The distances between molecules of gas in deep space are so vast that a compression wave would dissipate almost immediately. If you could somehow be transported to the space between stars and something exploded nearby, you would see the explosion, you would see the light, you would feel the radiation, but you would hear nothing. The universe, at its largest scales, is a place of absolute unbreakable silence, and perhaps that is fitting. Perhaps the most ancient and most enormous thing in existence deserves to be quiet. The largest known star in the observable universe is a hypergiant called Uy Scuti. If you replaced our Sun with Uy Scuti, placing it at the center of our solar system in the Sun's position, its surface would extend beyond the orbit of Jupiter, beyond Jupiter. The entire inner solar system, Mercury, Venus, Earth, Mars, would be inside the star. The asteroid belt would be inside the star, and Jupiter, the largest planet in our solar system, would sit just inside or just outside its surface, depending on the exact measurements. And yet, in the scale of the Milky Way, Uy Scuti is invisible. A single star, however vast, in a galaxy of 400 billion, less than a grain of sand on a beach that stretches to the horizon. Despite the mind-bending number of stars and galaxies in the universe, the overwhelming reality of the cosmos is emptiness. The distances between stars are so vast, the distances between galaxies so much vaster, that almost all of the universe is nothing. If you removed all the empty space from every atom in the human body, from every person who has ever lived, all of humanity, compacted to its actual solid matter, would fit in a space smaller than a sugar cube. What we experience as solid, what feels real and permanent and there, is almost entirely nothing. Electrons orbiting nuclei, vast, empty spaces between them, forces pretending to be solidity. We are more absence than presence, more space than substance. The universe made us out of nothing, mostly, and called it something. Quantum mechanics is the physics of the very small, and it describes a reality so strange that even the people who understand it best often say they do not truly understand it. At the quantum scale, particles do not have fixed positions, they do not have fixed speeds, they exist in a blur of probabilities smeared across space, until the moment they interact with something. An electron is not somewhere. It is everywhere it could possibly be, simultaneously, with different probabilities for each location. When it interacts, it chooses, or something chooses for it, and the universe changes accordingly. This is not a limitation of our instruments. It is not that we don't know where the electron is. It genuinely is not anywhere in particular until it is. Some interpretations of quantum mechanics suggest that every quantum event, every moment of uncertainty resolved, causes the universe to branch. In one branch, the electron goes left. In another, it goes right. Both branches continue to exist. Both are equally real. In this view, the universe is not a single timeline. It is an endlessly, constantly, unstoppably branching tree of all possible timelines. Every decision you have ever made, every quantum event in every atom in your body, every interaction in every particle, in every star, each one a branch point, each branch continuing forever. In some branches, you are not asleep. In some branches, this planet does not exist. In all of them, the universe continues. The universe may have begun as a quantum fluctuation, a random momentary variation in energy in a quantum vacuum, a brief probabilistic blip that crossed a threshold and triggered the rapid expansion that we call the Big Bang. In this picture, the universe did not come from something. It came from the quantum mechanical uncertainty of nothing. Nothing is unstable at the quantum level. The vacuum of space is not empty. It is full of virtual particles flickering into and out of existence, borrowing energy from uncertainty. And perhaps, at some moment in the absence of everything, one such fluctuation did not borrow energy and return it. It kept it. It expanded. It became everything. The universe may be a loan that reality forgot to call in. During deep sleep, the human brain does something remarkable. It activates a system called the glymphatic system, a network of channels that opens up primarily during sleep and uses cerebrospinal fluid to wash the brain clean of metabolic waste products that accumulate during waking hours. Among the waste products cleared during sleep are proteins associated with neurodegenerative diseases. Sleep is not merely rest. It is maintenance. It is the brain cleaning house, preparing for tomorrow, repairing what the day has worn down. Every hour of deep sleep tonight is your brain doing its most important work. The universe spent billions of years building a brain capable of understanding it. That brain needs sleep to keep working. This is not a small thing. The human brain contains approximately 86 billion neurons. Each neuron can form synaptic connections with thousands of others. The total number of possible neural connections in a single human brain is estimated to exceed the number of stars in the observable universe. The universe is vast, beyond easy comprehension, and yet inside the skull of every person resting tonight is something that may be, in terms of complexity, even more extraordinary than the cosmos itself. The universe created brains, and brains created the ability to understand the universe. Something that began as energy and quarks became in time capable of contemplating its own origin. That is perhaps the most remarkable thing that has ever happened in 13.8 billion years. Consciousness remains the deepest mystery in all of science. We know a great deal about the brain. We know which regions are active during different mental states. We know how neurons communicate. We know how memory forms and how it can be lost. We know the chemistry of emotion and the neuroscience of perception. But we do not know, and have never known, why any of this is accompanied by subjective experience. Why there is something it is like to be you. Why the processing of information in your brain is accompanied by the feeling of being awake, of being present, of existing. This question is called the hard problem of consciousness, and it is genuinely hard. The universe spent 13.8 billion years producing matter capable of experiencing itself. How it did that, we still do not know. You are the universe looking at itself. This is not a poetic sentiment designed to make you feel better. It is a precise description of what is happening. The atoms in your eyes were forged inside stars. They were scattered across space by stellar explosions. They gathered into a planet. They became part of an ocean. They were incorporated into living things. They evolved over billions of years into the complex biological machinery that produces human vision. And now, those atoms, those ancient pieces of the universe, are being used to perceive other parts of the universe. When you look at the night sky, the universe is looking at itself through you. You are the cosmos become conscious. You are the Big Bang, 13.8 billion years later, wondering where it came from. Carl Sagan described Earth, as seen from 4 billion miles away, as a pale blue dot. A photograph taken by Voyager 1 in 1990, looking back at the solar system from the edge of it, Earth was a point of light, smaller than a pixel, a mote of dust suspended in a sunbeam, and Sagan wrote that on that dot, every human who had ever lived had lived. Every king and every slave, every inventor and every farmer, every act of love and every act of cruelty, every religion, every philosophy, every scientific discovery, every war ever fought over a fraction of that dot, every moment of joy and every moment of grief, all of it on a pale blue dot adrift in the cosmic ocean. Looking at that photograph, it is impossible not to feel the profound, clarifying smallness of everything we treat as important, and also the profound, clarifying preciousness of what we have. And yet that pale blue dot is extraordinary. Of all the worlds we have found, and we have found thousands, none has shown signs of life. Of all the signals we have searched for, none has come back with an answer. Of all the cosmic real estate in this vast and ancient universe, this small, improbable, water-covered world is the only place we know of where the universe has become aware of itself, where it has looked up at its own stars, where it has built languages and telescopes and cities and songs, where it has felt wonder. Earth may not be the only such place. We hope it isn't, but it is the only one we know, and that makes it irreplaceable. The night sky above you right now, whether you can see it or not, is the same sky that has watched over every human being who has ever lived. The same stars that guided ancient sailors across unknown oceans, the same moon that lit the paths of the first humans who walked out of Africa, the same darkness that has held every sleeping world since the earth was young. Countless generations have lain down beneath this sky, have looked up at these stars, have wondered what they are and where they come from and whether they matter. You are doing the same thing they did, across thousands of years and countless lives. You are connected to every other human who has ever looked up and wondered. Somewhere in the universe right now, a star is being born. A cloud of gas and dust is collapsing under its own gravity, growing denser, growing hotter, moving toward the moment of ignition. It will burn for millions or billions of years. It may have planets. Some of those planets may have oceans, and in those oceans, who knows? Somewhere right now, a star is dying, expanding into a red giant, shedding its outer layers into space, leaving behind a white dwarf or a neutron star or a black hole, scattering the elements it spent its life building back into the cosmos. The universe is not still, it is not finished. It is always in motion, always dying and being reborn, always becoming something new. The Big Bang set everything in motion 13.8 billion years ago. Every event since that moment, every star born and every star that died, every planet that formed, every ocean that filled, every cell that divided, every creature that drew a breath was a consequence of that first fraction of a second. And so is this night, this quiet, this moment of rest. The chain of causation that began with the Big Bang runs unbroken through 13.8 billion years of cosmic history, through the formation of galaxies and the death of stars and the appearance of life on a small blue world, directly to this moment, to you, resting. The Big Bang is still happening, in a sense. You are one of its consequences, still unfolding. The atoms that make up your body are effectively immortal. The hydrogen atoms in the water in your body were created in the first 3 minutes after the Big Bang. They are 13.8 billion years old. The heavier atoms, the carbon, the oxygen, the iron, were created inside stars that lived and died before our solar system existed. Those atoms have been part of nebulae, of stars, of planets, of oceans, of living things, of the soil, of the air. They have been through more than we can imagine, and when the arrangement that is you eventually ends, those atoms will not end. They will disperse. They will become part of the air and the soil and the ocean. They will be breathed by other things. They will be used again in ways we cannot predict, in things we cannot imagine. The matter that makes you up is immortal. You are borrowing it. We have reached the end of our journey tonight, traveler. 100 facts, 13.8 billion years, from the very first fraction of a second to the stars above you right now, to this breath, to this moment of rest in the quiet dark. You don't need to hold any of it. You don't need to carry a single word of it into tomorrow. What matters is that for a little while tonight, the universe told you its story, and you were here to hear it. You are safe, traveler. You are held. The universe is vast and old and largely indifferent, but it made you from its own material. Every atom in your body has been part of this cosmos since the very beginning. You are not a stranger here. You are not passing through. You are made of this place. You belong to it, not because you earned your place, but because you are woven from its oldest fabric. Tomorrow, the universe will still be expanding. Stars will still be burning. Somewhere, a new world will be forming around a young star in a distant galaxy. And on this small, improbable, precious blue planet, you will wake, and the journey will continue. But for now, rest, traveler. The stars will be here when you open your eyes. They always are, if you are still with me. If sleep hasn't found you yet, thank you for following me tonight, for traveling all the way back to the beginning of everything and making it this far. If this journey brought you some quiet, if something in these facts made the universe feel a little closer, a little less overwhelming, a little more like home, then perhaps there are other travelers out there who might need this too. If you feel like leaving a like before you sleep, it helps other sleeping souls find their way here. And if you'd like to travel again, we'll be here. A new journey whenever you're ready. And if sleep already took you somewhere in the middle of all this, good. That's exactly where you were supposed to go. Until next time, traveler, the universe is patient. It will wait for you. Good night.